All right. There we go. Excellent. All right. Thanks for coming to my session. Happy afternoon. I hope you've had a great uh, conference so far. I'm going to be talking about a plan for unplanned work, game days with chaos engineering. So, first, my name is Mandi Walls. I am a DevOps advocate at PagerDuty. If you'd like to get in touch with me, chat with me, whatever, I'm LNXCHK on most of the social media these days. Or you can always email me. I'm mwalls@pagerduty.com. I love to talk to folks about what they're doing with their incident response and incident management and all that great stuff. So reach out if you have any questions. And I'm not going to talk about anything about the PagerDuty platform. I'm going to talk about how we do some things internally versus, how other folks might do them. If you'd like to talk about the platform anytime too, you can always get in touch. We're happy to talk about the product. All right. So we work with a lot of organizations that want to improve how they manage incidents, right? Things happen and getting better at incident response, kind of a double-edged sword. You want to get better, but like with most things, getting better means practicing. But to practice, you have to have more incidents, but you definitely don't want to have more incidents. Incident response is like this organizational muscle that I have to you have to exercise it. You have to practice with it to keep it sharp, right? You've got sort of workflows and you've got communication patterns and you have people that have to know where they're going and what they're doing. And all that stuff doesn't just happen, right? We have to set it up, we have to talk about it, we have to work on it, and we have to practice it. We don't want to be at a time where we've got a real issue and folks don't know what to do or where to go or who to talk to or any of those kinds of things. So we want to set ourselves up for success well in advance of anything bad happening on the platform. So we refer to incidents as unplanned work, right? You have your planned work, the things that you're scheduled to do, and you want to add features or do bug fixes or whatever to the things that you work on. And then incidents are all that other stuff that happens that you didn't plan for. And sometimes they impact customers and the reliability of the system. So they're pretty important, right? They interrupt our day, they slow down the planned work that we're trying to do. So we want to improve how we handle them so we minimize their impact and keep our reliability within our tolerances. So one way to accomplish this is to talk about game days. Some organizations are maybe already headed down this route, and even individual teams, right, can use a game day. But what is a game day? So back up a little bit. Game days are a simulation exercise. You add some failure to the system or service that you're working on. The practice is really a way to inject failure or errors into the system and investigate how it responds. What does it do? Does it fail over? Does it do something better? Right? But also, it tests like what your human observers can see and then practice how the system should be recovered in the event of an actual real failure. So game days really should include all the folks who would normally be involved in a real incident, right? And that often includes folks outside of your subject matter experts, like maybe your incident commanders, or maybe you have a scribe that will join a large incident call to take notes for your post-incident review. Here at PagerDuty, we refer to them as Failure Fridays, and the years, they have evolved into what we call Failure Any Day, because teams can kind of do one of these anytime they want to. They can step into a production or pre-production system, inject some failure around the code that they're working on, and determine what's going to happen. But the point of the exercise is to make sure that production operation systems are doing what we need them to do when we need them to do it, especially if something is wrong. And there can be a lot of different subsystems that get included in these kinds of exercises. Some things that we take a look at: the metrics and observability tools. Are they giving us the telemetry we expect when we inject these errors? Is it timely, or is it something that we're not sampling enough time around? Are there escalation policies, notifications, incident rooms, chat room, Zoom call, whatever? Do they work? Can people find them? Do the notifications go out appropriately? All that great stuff that we need to know is going to happen in the event of a real incident. And then if we need to or want to push a fix in real time, how fast can we do that? Do we need higher authority to be allowed to do that? Is someone on the call going to be able to establish, yes, we need to push this fix? And are they able to actually make that decision? So, all those things we really want to put together in advance so that we're not scrambling when we have an actual incident that's impacting customers, right? Because real incidents are going to be super stressful. Like, and some folks handle them way better than others. Definitely, there's that. But like, not everyone has the temperament to be sort of calm and think through things when they're super stressed in an incident. So you want to have some feeling of familiarity. Yes, we've kind of done this before. Yes, I understand that, we have practiced where to go, who to talk to, how to fix the thing in advance of there being anything actual happening. So we want to give folks a chance to sort of experience all of it before something really bad happens, and they get that sort of familiarity. So when we want to go into a game day, we want to have a goal. And maybe it sounds cool, just go through a data center, pull cables, or maybe you're scrolling through your assets lists in a public cloud and just delete something randomly. But that's not where we're starting with the kind of game days that are going to help us really improve our reliability and resilience, right, as part of our production operations. So we want to go into this whole exercise with a plan and choose the experiments we want to do with a purpose. If we're fixing a bug about a slow query, we don't want to just go in and pick something randomly. We want to choose somewhere in the system that's going to ex- really explore what happens if that query is slow, or what happens, did we actually fix that slow query? And those kinds of things are super important. So part of what gets incorporated here then is now sort of referred to as chaos engineering. You might also hear this called fault injection, right? That sounds a little bit more serious for a lot of folks. Chaos engineering, something that got started about 15 years or so ago at Netflix. You may have heard about their Chaos Monkey, Chaos Army kind of projects that they were putting together. And they were doing this on a much larger scale. Like, a lot of their practice in the early days could impact anyone and was often a surprise. And we'll talk about that in a little while. But at that baseline, chaos engineering lets you compare what you think will happen to the system to what actually happens when there's a problem, right? You literally go in and break something on purpose to learn about it and figure out how we can build more resilient systems around that particular kind of failure. What can we do to sort of insulate the customers from a slow query, an unavailable backend, high disk IO, whatever we want to look at in a very intentional way? The chaos, like I said, can make it sound kind of scary or a little too irreverent. So that's why you might hear some folks refer to it as fault injection, because that sounds a little bit more serious, because it is kind of a serious thing to do. We are going into our production systems and tinkering around. And when we combine chaos testing and experimentation with game days, that gives us a framework for teams to sort of create and then execute different failure scenarios in production and pre-production environments to really get a feel for what the system is going to do, and then also what the human teams need to be able to do when the problems arise for real. So we're using chaos engineering and failure Fridays, game days, to validate the assumptions we have about how our systems are going to behave when they meet a problem in the production environment. The goal of combining the structure of chaos engineering, hypothesis testing, and all that kind of stuff, and we have specific tests, and then we add in a regular cadence of intentional practice. It's really to make sure we're putting the product in front of the customer that's really the best system possible, the best thing we can give them as based on the system as we know it right now. We have, added in some resilience for the known components that we know might give us trouble. And it's really just kind of a cycle. We have a steady state where we're sitting for a while, and we've got some code in there. Maybe we've got like a burn-in period, and then we think, okay, well, what's going to happen if we see this particular kind of error that we saw in the past? And then we can do an experiment. We can verify that either what we have in there now is good or bad, and then we can make improvements from there. And it really should be sort of continuous. And especially if you're using, agile processes and you're putting new code into production all the time, adding in, a period of doing some testing like this will help make sure that all that code that goes in is behaving well and you know how to handle it if there's a problem. So our goals for these exercises are really to learn and improve and to focus on the customer experience. Really, that's what we're after. We want to make sure that all the work that we're doing isn't negatively impacting the customer or internal users if you work on an internal system, right? We want to keep those users happy and give them the best experience possible so that they keep coming back, right? So when we're planning out testing programs and failure scenarios, we want to keep the users in mind, right? We want to improve the reliability of the components that they rely on the most and where they expect the best performance. And that might mean that some things in your system, maybe don't focus on, right? But other things will, get to the point where you test them pretty much constantly because they're in like the main path that customers use as they're using your product, right? So we focus on those components that are going to make the users the most stressful when they go down, right? So our whole process is going to help us improve all the reliability of all these services and preserve that core experience when things aren't working as well as we'd like them to. Because stuff is going to happen, right? You might have a lot of third parties you rely on. They have their own availability that they're able to produce. You have the internet just being crazy one day or not or other. That might impact the performance of your systems as well. So we apply what we learn to make sure our systems are built to handle those kinds of things. And when we put these exercises together, you don't have to plan for a whole day, right? People say, oh, we're going to do a game day or we're going to do Failure Friday. And you think, oh man, like 8 hours of testing, that's kind of wild. Like that's a lot of resources to use. But as you improve the practice and get used to planning the hypotheses, putting your experiments together, and figuring out how you want to work it, these can be super short. Like our teams are pretty well disciplined in how all this works now. Like I said, PagerDuty's been doing these for about 10 years. So we have a bot that lives in our Slack, and it notifies everybody that, hey, a team is doing a Failure Friday. And they don't have to be super long. If you go in with an experiment in mind and you learn what you needed to learn, you can just be done, right? This one lasted from 1:07 p.m. to 1:31 p.m. It was a short, focused experiment, but that still gives the team, plenty of information about, maybe they were looking at, did they fix one particular bug? Or is there one sort of corner of this code that we need to make sure that it works when it's under production load? Whatever the case might be, once you've learned what you need to learn, you just call it. So you can have these as part of your regular cadence for software releases. They don't have to be planned quarterly or twice a year. You can do them pretty often in different scales. So maybe there's some prerequisites. Let's think about that a little bit. To have a successful chaos testing and game day practice, you need to have some things in place first. The big one, of course, is going to be your monitoring and telemetry. Having those there, it's absolutely fine to use your game day to sort of flex those and see, oh, maybe we're missing something, especially for like log messages and other application output. You're not sure what it's going to do when it gets into production. There's that. But you need to start with at least enough monitoring that your test scenario actually worked, right? For example, if you're looking at how, an application responds to a dependency being offline, you want to have at least some monitors for that scenario that makes sense for your platform. Like somebody needs to know, yeah, that backend is actually unavailable, and maybe your the thing that consumes that says, I can't reach backend, blah, blah, blah. So that folks know, yeah, the test is actually running, right? The other part with the monitoring and telemetry is you have to make sure everyone has access to it, right? It's super common, as I know, like licenses and things like that for some of these products are expensive, but everyone involved in the experiment needs to be able to see what's going on. And you don't want folks like copying and pasting and screenshotting and exporting graphs everywhere to share with everyone. So the folks who are involved need to have access. And that's an important thing to remember. Number two, you want to set up your response process. Chaos testing, game days, we want to practice all of this stuff, right? And so make sure you've got the way you've got things set up the way they would be in an actual incident. So depending on how you run your incidents, you may have for a larger experiment that incorporates a number of different services, you might want to call in an incident commander. You might want to appoint a scribe. You might want to actually then do a post-test review, just like you would a post-incident review. What did we learn? How long did it take? What did we do to fix it? Did we need to change anything? All those kinds of processes, super helpful when you're doing this kind of practice. It gives people knowledge of that flow, how you're expecting them to respond in real time to an actual problem. Then make sure you're putting your workflows together. Lay the groundwork for how much experimentation you want the team to do during the test. Are you ramping up the amount of some error, or are you changing thresholds or those kinds of things during a test? In a real incident, your SMEs they might want to push code, right? Or configuration updates or roll something back. You can test some of these during a game day if you want to, right? Make that choice. Do we want to actually try this out, right? You can. It's great, right? It's a practice. So you can actually take the time to do that, right? You don't have to, right? Finding the issues and pinpointing the places for improvement might absolutely be enough, especially if you just want to run a short test. But if you have some time and some flexibility and you want to maybe roll forward on some changes, talk about that with your team as well. And then finally, think about the improvement. Think about the things that you're learning. What happens after the game day? Too many teams spend all this time planning and executing game days and experiments, and then they're not able to put those improvements back into the work stream, right? And that's a huge waste of resources then, right? If the reliability improvements you learn about during an exercise like this, how do you then get those changes back into the workflow? So you may need to incorporate your product management folks into your game day planning and let them know, hey, we're going to flex this particular problem that we've been having. We're going to poke at this a little bit. And then we need to be able to prioritize what we learn so you can get that back into the production environment for real, right? So improving reliability, we know it's a long range process, right? It's not something that you kind of are one and done, right? It takes plenty of time. It changes every time you put new code into production. So we want to take some time when we run these to plan ahead and make sure you get the most out of it. And that just means folks have access to the things that they need to, they know where they need to go, and you know that whatever you learn is going to come back into your workflow. Then we won't go deep into the other things, but we can focus on a little bit of how you incorporate incident response into a game day like this, right? These are excellent opportunities to flex incident response muscles, especially for folks who are new to your team, folks who don't spend a lot of time being on call. So there's less likelihood that they get pulled in to like a major incident, right? So they're maybe not comfortable with what happens when you have a major incident in your organization, right? And it just gives you that nice, calm place to practice what you want folks to do when you do have a real incident. You don't have to mobilize a full incident response every game day. You certainly wouldn't want for those short little tests like I showed before, right? Those are tests that are sort of incorporated within a team and they handle that whole thing. They're more like a Sev 4, Sev 5 incident, things that are a little less important, right? But for game days and practice incidents that you're going to incorporate a lot of different teams into, it's a good idea to get organized around how this would work if it was a real incident that was going on with the same systems, right? It's an option to keep in mind. Responding to major incidents, especially things that impact users, and even better when you've got stuff that crosses teams and services into lots of places in the environment, it takes a lot of coordinated effort practice. And if you aren't already doing it, like maybe you've experienced a larger incident where people are just kind of like crazy and don't know what to do, right? So we want to help folks, help their team work better within the response framework, right? And we want to help other folks that might not be part of your team, but you might have incident commanders or other sort of coordinators that come into play when you have a large incident in your organization, who are there really just to help or to help mobilize or to sort of help organize the incident, right? So the more you give those folks some opportunity to practice, the better off they'll be, and then the better off the whole organization is down the road when you do actually have a regular incident. And we do these occasionally. So like you have the sort of failure any day thing that any team can do at any time, right? They just kind of like add it to a list and we're going to do it on this day, let folks know, and then the bot takes over. And for larger ones, they might come into our incident commander channel and say, hey, we're going to do a failure exercise on this day at this time. It's going to reach these number of services. And we like to have an incident commander present to help us, coordinate and work through it. And that's totally fine, right? They happen every few weeks. Different teams pull them in to different parts of the environment or whatever. And it gives the incident commanders a way to practice, right? It's not a real incident. They can turn it off at any time. We're going to go through the flow. And also gives the teams, a way to practice. Well, okay, we've got an incident commander here. They're going to be asking us to focus on these sorts of things. What's the impact? What are the customers seeing? That whole practice is super helpful for new folks and folks who aren't on call all the time, right? With all of that, we really want our incident response practice to improve over time, right? And our game days are a key way of sort of injecting that improvement process into the whole thing, right? It helps everyone feel more prepared, right, for an incident when it does pop up, even though, we just kind of been practicing, right? And it replaces the sort of chaos of an incident when folks are more familiar with the process and they can be more calm, right? And it helps them sort of get in the right mind frame for responding to an incident when there actually is something wrong with production. So you organize in advance and let folks practice and set, explicit expectations. And you can do this throughout your entire incident response workflow, right? It's going to help sort of that whole end to end of what an incident actually looks like in your environment. And this might vary from what we do, absolutely, right? Depending on how you have things set up. So when we're looking at and planning for the experiments we want to add to our game day, we choose our tests. We have then, a checkpoint. Do we have an appropriate alert for this scenario? If I've taken a service offline in a black hole test, right? That's what that's called. This backend's no longer available. Does the system actually alert somewhere? Does something tell me, hey, that backend is offline? Do the consumers of that backend have a log message, cannot talk to, putting hold down, some other process around it, right? Do I have that for latency tests, for disks or IO? Like any of the tests that I want to cover, do I actually see that happening in my telemetry? If I don't, what else am I not seeing, right? I might be flying blind, right? And that's not good. When alerts fire, what happens next? Are there folks that should be notified? Hey, if this backend is down, we want somebody to take a look at that, right? And make sure it gets fixed and brought back up. So if I do have that alert, I should have the folks who are responsible for that service on the call to be able to say, we can bring this back, whatever the case might be. Then part of that is, does the team have correct contact information in your paging platform? Folks get new phones all the time, right? So make sure they have things updated before there's a real emergency and you need them. and it turns out they have their old phone in the platform and not their new phone, right? When everyone knows something's up, then where do they go? How do you coordinate? Are you coordinating a team chat channel? Do you have a conference call? How do folks find that information? Do they know where to go and can they get there quickly? Right? And then finally, when we're thinking about our troubleshooting, before you're in a real failure, right? What are we planning to do? Right? Do folks have access to all the dashboards they need? We talked about telemetry a minute ago, right? Can responders access the hosts, the repositories, the configuration files, whatever else they might need in order to fix a problem, right? Has everyone been added to the management tools for your platform? Do they know how to use them? These kinds of game days are also a good time if you have the bandwidth, right, to practice restarts, practice scaling up, practice failing over, so that everyone on the team knows if your turn to be on call, we need to restart this thing. Here's how it works, right? So you're not scrambling around trying to find one person who knows how to restart it, especially for large complex things that might need to be restarted in a particular order, right? No, everyone knowing how to do that is super important. And then finally, decide when you're going to call the experiment over. It might be time bound. You're going to we're going to look at this for 10 minutes. That's all we can really afford because there's going to be some minor customer impact. It could be more flexible, especially if you have things sort of partitioned out that it doesn't affect all the external users. It's, maybe something that is partitioned to only impact the employees' personal accounts that they can test in, or something that is still set under feature flags that you have a cookie for, or something like that you can practice without impacting regular customers. They can go a little longer, right? Because there won't be any impact. You might be super flexible, right? When we feel like we've learned what we wanted to learn, we can call it done, right? And you maybe don't know what that's going to look like. But things can be super quick, like I mentioned before, and you have that sort of flexibility and that option to just go in and test the things that you need to. The important part really then is to set goals. We want to go into any of these exercises with a set of explicit goals in mind, right? We're planning this hypothesis around the things that we want to learn. We might have a general goal. We always have, right? Improve the reliability of our services. That's always our high level goal, right? Everyone's striving for reliability. But to get the most out of the game day, we want to get to the nut of what we're looking at. So do you have a dependency that flakes out periodically? Maybe your next set of tests are going to show that you've put some defensive coding in there, right? That improves the performance of your service and what it shows to customers. Maybe you've got things that slow down under heavy load and you have a lot of trouble mimicking that in your pre-production environments. You want to test that in production under real load and see what happens. Maybe you've got users that are reporting that some flow is really slow, but you can't duplicate it in other environments. You really need to see it happening in real time in production, and you can do those kinds of things as well, right? You can also focus on larger problems. Some folks will use these opportunities to look at how they mitigate like a DDoS attack, or what they're going to do for like a data center level failure, or one availability zone is offline, or whatever they want to look at there. So you can also set like big goals and do these that way, but make sure that everyone knows what's going on there. And we're hypothesizing, right? What do we expect to find about all of this? Do we have things that are already in place when we expect our systems to scale up? Maybe we expect them to fail over. Maybe we're just expecting a slowdown as the systems try and cope with load, right? Or maybe we have something a little bit more graceful that happens, right? That's all fine, right? Any of these is a place to start with our improvement, right? But we definitely want to set the initial hypotheses. We built this system in such a way that we expect XYZ to happen during this particular test. And if you built it and it doesn't actually do the thing you expected, somewhere your assumptions aren't right? So you want to investigate that as well, because you're then building on the wrong foundation. If the system isn't behaving the way the people who built it expect it to behave, something's changed, right? Something's not right in that connection. So you want folks to have the ability to be able to go in and see what is going on when you're doing that. And that's going to give them their baseline for improvement going forward. It may reset some of their expectations of the system. And it might be based on something as simple as, oh, we assumed a different version of this library that behaves in a different way, or the whole dreaded "it works on my machine" kind of idea that things behave differently when they get into production. And that becomes another place to start investigating. Why doesn't it work the same? Are things radically different? Do we need to change our development environments to better match what we're going to see in production so that we can improve our reliability that way? So then that's what we're doing. We're looking at what actually happens. We want to record it. We want to make sure that we're saving the charts and the graphs that we looked at, right? And those things are super helpful because they can be turned into run books, right, for future incidents. We practiced this incident with a black hole experiment. This back end was no longer available. Here's how it shows up in the graphs. Here's how we fix things. Here's what we do. And you can build all of that stuff into a run book. So when you're collecting this data, right, it's not just about the things you first thought to look at, but maybe any other related information that's going to help you in the future when you need to diagnose these things in real time. And then talk about what you learned. You went to all this trouble, right? We planned this stuff out. We got it on the game day calendar. We have all this stuff that we put into our goals and our hypothesis and our planning and our experiments and all this work that went in. We used all these resources, right? Then what do you do with it? You want to talk about what you learned, right? Share it with the other teams in your organization who can benefit from it. If you hold like a post game day review, invite everybody so that anyone can come in and say, oh, what'd you guys learn from working with this experiment? Especially if there's other teams that share the same kind of stack that you have, right? There's lots of places where there's only, 3 or 4 different stacks that teams work on, but there are many, many teams, right? So if you're in a particular stack and you've got lots of sister teams that work in the same kinds of environments, everybody can share the things that you learned from your experiments. And hopefully they'll share their experiments with you so that hey, we tried this, it behaved this way, here's what we decided to do that remediated it, and it looks like this. We changed our garbage collection, or we changed where we do logs, or whatever the changes might be, that then helps everyone across the environment improve their reliability for your customers, right? So share all that stuff out as much as you can. Because we want to put the stuff that we learned to good use. Everyone wants to improve the reliability, the resilience of your systems. It's kind of our requirement, right? If it's not available, users can't use it. We want to be able to then balance into the work mix this non-feature operational improvements and get that in there with the regular feature work so that we're providing the best experience for the users. All of the findings from your game days are probably going to generate some work or some improvements that really need to go into the backlog for your service. You might find, just as a baseline, you need better error messages in the application log. That's not a feature that customers are going to see, but it's going to impact your ability to respond to incidents. You might need new defaults for memory allocation, garbage collection, disk IO, whatever it is. Again, not going to be seen by your customers, but it's going to impact their experience if things go wrong. You might need better timeouts. You might need more robust feature flags. You might need a better way to experiment with things. You can learn all of this stuff during your game day that is a little bit upstream of the end customer experience. But if you don't fix it, things don't improve, right? And the time that you need it during a real incident, you're going to wish it had gone back into the production environment. So any number of new improvements can be uncovered, and some of them might be super simple and some of them might be more complex, but you want to have the ability and the Yeah, the ability to get them prioritized into your backlog. So incorporate what you learn, talk to your product managers, balance those things into what it means to improve your product. And then as your team gets more comfortable with defensive or resilience techniques, it's going to be easier to use those in regular practice. Like you're going to learn some, and then the next time you need to incorporate a backend, you'll be like, oh, well, here's this library we wrote after this game day to help us with hold downs or timeouts or whatever it is, right? And that's going to help your whole team learn from all these tests downstream, but also potentially your whole organization. So keep those things in mind. And if you're using SLOs, right? If you're not, that's a whole other talk, and you should look into that. But if you're using SLOs, you can use your game days to help you revise and sort of revisit those and just make sure they're still appropriate for the system as it currently lives, right? Because you go in, you set your SLO, and then the system has a mind of its own, and it goes off and it meets the users, and the users do crazy things. So when you have a game day, when you have the ability to inject some faults into things, it may show you that, hey, this SLO we have around this particular component is maybe too aggressive, and it's going to be really hard for us to continue to meet it. And you can use your game day to reset that and be a little bit more rational about it. Because remember, your SLOs are your internal benchmarks for your team and your projects, and they're not published to your users. You don't have to share them out. But because they're internal, you can then change them as you learn more things about the system. You may find that they're too loose and you can actually tighten them up a little bit, or that they're, like I say, too stringent and it's going to be hard to meet them. So as you get better at game days and incorporating your knowledge into your practice, you can then start to actually use it then to also practice with your SLOs. So there's lots of benefits there, right? Some of the questions we get then around game days. Number one is, can we run it as a surprise? Because that's the way these kind of started out, right? It's like you didn't actually know what was going to happen. Kind of this vague, oh, we're going to do a game day on Friday, but like no one knows what's going to happen. And if you're just getting started, definitely don't do those that way, right? Once you have your patterns and practices well honed, then yeah, maybe you can call a surprise. But like we've been talking about, the whole practice of this is very deliberate. It's explicit. We want to set goals well in advance and talk about what we want to learn before running the game day in the first place. If you're looking to run a surprise game day, be very, very clear about what you're hoping to accomplish. And that might be like a disaster recovery practice, right? Those are often, the things that folks want to run as a surprise. What would we do if we lose our main component data center? Fine. Like we're going to call that sometime in the next 2 weeks. Be ready. Okay. That's a scenario that sometimes works. Just make sure that folks have already practiced it within their own teams, how to respond to this kind of stuff, right? That they're already ready for the whole thing. There's a lot of pre-work that needs to be done there before you call in a major strike against your production systems for the fun of it, right? And in a way, it can feel more, I guess, real to run surprise game days because we don't know when a real incident is going to happen. But if your team isn't consistently getting through planned scenarios, a surprise one isn't going to magically make them better. Like you need to do more practice with them so they're getting through their own exercises successfully. And then when should you do these? We do these all the time, right? Just because we have, the infrastructure to sort of partition accounts, and we have a lot of feature flags that we use and things like that help teams sort of contain the blast radius of the exercises that they're going to do, right? So if you don't have that in place yet, thinking about when to do a game day that might impact the user experience is an important thing to take into account, right? The short answer is really you can do these anytime, right? Especially in pre-production, like do them whenever you want to, really, and just make sure somebody else is not doing one. But if you have smaller events you can do kind of anytime you want to. If you want to do a bigger event that's going to impact customers, make sure you're doing them when things are already okay, right? And this is another place where if you're using SLOs, you kind of know when things are running pretty smoothly, right? And you also know when things are not running smoothly. So if your users are already unhappy with the reliability of your application for whatever reason, you don't want to do a test in production that might impact their experience even more. Even if you mean well, right? They don't know that, right? So you don't want to blow through your error budget on testing because you might need it for real issues if you're having some struggles, right? There may be times, yes, when you really need to get in there in production. We think we fixed this thing that's been giving us trouble. You want to do that, that's fine. But for sort of their everyday kind of testing, that's not the time to do it. So look for times when you can do shorter, focused tests when things are calm and running well, and make your plans to run your chaos testing against new features after they've had some burn-in time, unless they sort of go in and aren't behaving well. In that point, you might want to just pull them back and test them again in pre-prod. But if things are go in, burn in for a couple of weeks, and then do some testing around them to see how they do. And then the opposite of that is, when should you not game day? And this is going to vary in different organizations, but there's a couple of things to keep in mind, right? Don't game day right after a reorg, right? Give folks time to get acclimated. I love, everybody loves a reorganization. It's a time to like get some new things to work on and new people to meet, but that's not the time to do a game day. Also, don't wait until the week before your busiest season and then game day. Today is Thanksgiving in the United States, so like no one in the US, and especially in retail, should have been doing game days anytime in the last few weeks, right? You do that stuff in like July, August, when you're planning way ahead for what's going to happen for your biggest season of the year, right? And if your season is in the spring, you're practicing over the winter, right? Just depends. So reconsider doing your time doing game days if your business partners and project managers aren't on board as well, right? If you are going to spend a lot of time putting the resources into these experiments and the product manager says, nah, we don't really need to put those things back into the product. We really need to, get on and ship these features. This is more important. Then your game day is probably not the thing that you need to be doing, right? You need maybe some management advocacy to help you get more non-user facing features, this operational features into the product to help your reliability. So I know that's a lot of things to think about, right? There's a lot of ways to look at this, a lot of work that you can do across your organization, things you can think about. But in summary, these are super powerful methods for helping you improve the reliability of your systems in production. So when you go into them, you want to make sure that you have a plan, right? We want to test these things based on code we put in a couple of weeks ago, or based on this bug report that came in, or based on this performance issue that we're having. We have a plan. We're going to go in and be intentional. We're going to look at this for 10 minutes, or we're going to go in and look at this and we're going to try these 3 configuration changes to see if something fixes it. That's what we're going to do. And then time box that. And then use what you learn. Share it with the other folks in your organization. Write it up. Improve your run books. Do all of that kind of stuff that's going to help you when you get to a real incident. And it might not just be the stuff that you learn out of the code and the application. It might be, we tried to organize people into this Slack channel and they had trouble finding it. So we need to make sure it stands out in our list of 10,000 Slack channels, or we couldn't find the Zoom call, or this didn't work, or that didn't work, or so-and-so didn't have permissions to access the monitoring tools. All of those things are learnings that come out of your game days. So we have a bunch of resources that are, if you're not a PagerDuty user, they're out there for you too. And you can scan that QR code, or they're there on that bit.ly link. And if you'd like to learn more about incident response, you can do that at response.pagerduty.com. And we'd love for you to listen to our podcast, where we talk about all these kinds of things and more with different folks from around the industry. So thank you for joining me today. I hope that was useful for folks, and I hope you enjoy the rest of your event.